What I want to present today is what we in NFDI for CAT have developed to develop SKOS vocabularies with Excel and GitHub. And this is now ready for general use, and we are starting to use it regularly since June approximately this year. In NFDI for CAT, we have a lack of semantic engineers. So there are just few people who really understand it in all detail, I have to say. And then we have lots of institutions from different areas of catalysis. Catalysis is a very broad field, touching from heterogeneous catalysis, which has a lot of material science in it. Then we have homogeneous catalysis, which is organic chemistry. And then we have biocatalysis, with also has a lot of gene knowledge included. And we want to, in principle, unite the different catalysis disciplines in terms of their data, which is a big challenge. And so initially, like Alex already pointed out, we had a look what is available. So in catalysis, we defined, or in the NFDI for CAT, we defined a data value chain, starting from lab work on synthesis, operando spectroscopy, performance characterization, or just material characterization. And then if you want to build a chemical process in larger scale, you always face some heat and transport issues. You need to know kinetics, which is just another level of research and also another data domain. And then in the end, you want to design your whole process. You want to integrate all these aspects of a chemical plant. And ideally, you could reuse data generated in the earlier stages. And this is a big challenge, and it's currently hardly done. Of course, in a company which does all the steps in one house, that works, but from one company to the other, or from research institutions to research institutions, or to companies, it's a very difficult process, and most data are just shared via Excel tables or something like that at the moment. So here's another look on the ontologies we have identified in the various areas. So there's a lot available, but unfortunately, all have just small overlap with what we need. And so it would be extremely difficult to use this, maybe with a terminology service, but it was not available by that time. And also there's lots of information missing in these ontologies. So the conclusion was that much has been developed, but unfortunately not for us. So we decided that we need to fill the gaps that are there. And since I said, so we have a lack of, we have few semantic engineers, but of course we could not approach all these domains in one project with few people. So we decided not to go to the highest level of the semantic spectrum to develop ontologies from the beginning, but we identified as an intermediate ground the development of vocabulary, so thesauri, which can be expressed in SKOS vocabulary language or data language. And so there we can also expect that we can reuse the definitions in ontologies or in other data models, like if we define in LinkML models or so, we don't need to have OWL ontologies to refer to, but SKOS concepts are completely fine as a basis. So now, what did we start with? So we formed, so like I said, so before NFDI for CAT, there was no catalysis related vocabulary existing. And in the project, we formed a task force to deal with the development of the ontologies and metadata standards. And part of that is the development of the vocabularies. So initially, we had a group of domain experts from all these different areas of catalysis, and they collected around 2,500 concepts. And what we used was a Excel template based on VocExcel from Surround Australia. And then we used Google Sheets or the Nextcloud or so to coordinate the development or the collection of the terms in an Excel file. But of course, then you lose a lot of history and you don't know if someone corrected something, so you cannot diff it. And so it's not very appropriate if it gets large. So it is good to have a first collection, but after that, there should be a better way to deal with it. And then we had to look at various SKOS-related tools, if they are suitable for this collaborative development that we plan, and especially if they are suitable for non-experts. And like you guessed, so we were not really happy with what we had. So we decided that we need something else. And the main needs, what we have is we want to enable contributions from the community and especially from non-experts. Then, of course, like if you are used to open source development, you want to track discussions and resolution about concepts and relations that go into this vocabulary. We need version tracking and the provenance tracking. So we like to give credits to people contributing to the vocabulary, and with Excel, you all lose this. So we need a more approach from software engineering. And in general, the idea is to keep the effort low for the contributors, but also for the maintainers. So that's why we stick just with GitHub and Excel, which is probably as minimal as you can get. And then another thing is what is important is that if there's something accepted, you want to make it available quickly to the person contributing. So we directly want to publish new versions which can be reused after the contribution. And then also looking at what is available. Some of these ontologies or tools have not the ideal license to reuse. So we said we want to do all in BSD or some licenses or CC0, which are completely free to reuse. And in principle, like I said already, open source development has already solved a lot of these challenges, but it's not applied everywhere to SKOS, maybe to ontologies in Obo Foundry, but not so much in the linked data world. And so our goal was to adapt the modern contribution workflow from open source projects to the NFDI for CAT vocabulary development. So I just show the workflow that we created. There are few existing workflows, but they differ. So I don't want to comment about all the other version or tools that are available, but just stress what we do. So our approach allows the contributor to just send a pull request with the Excel file. So which means it, for someone not used to Git contribution, it's enough to use the graphical user interface of GitHub and just drag and drop the Excel file as there into a folder, and then it's automatically creating a pull request. So there's hardly anything you need to know about working with Git. So afterwards, so from this creation of a pull request, we started a CI pipeline, which does a check of the Excel file. So is everything correct? If it is correct, it converts it to SKOS, to turtle file. And then it does a validation of the created turtle file using Shackle language. So we use a voc profile as a Shackle shape file. And then we also create documentation as everything is running well. And so the documentation and the SKOS that's created is available to the contributor as a GitHub artifact. So in the pull request, you get a zip file with everything that is generated, and then you can also download it and have a look at it. And you may see if there's an error detected, what is wrong. So we highlight the bad line in the Excel file, for example, if it's identifiable, what's the problem. So it's easy to fix a problem. And then, of course, you can do, like always, you can commit more changes, and that starts again the pipeline until you finally then are happy with the result. You pass everything, you get the SKOS file generated. And then at this point, when the pipeline completely succeeds, we remove the Excel. So we don't want to keep Excel in Git. We just want to keep turtle files in Git, so that it doesn't make sense to store binary files. You cannot diff them and so on. And it would be just a duplicate information. So Excel, we just need as a medium to transport the information into Git. And then there's also, of course, some editors which can help the contributors by reviewing the contribution, discussing, helping, and so on. And finally, so when it's approved, then it can be merged. And on the merge, we build again the vocabulary, the main one, with the new contributed changes, and publish it immediately also from the pipeline. So that's the basic idea. Another thing is, like I said, we want to have Excel as a user interface. And that's because people really like to use these features like filtering, sorting, and I mean, just copy pasting something. So it's quite convenient to work with it. And most of they know it. I mean, compared to TSV also, it's much more convenient to directly work with Excel files. And then also another point, SKOS is relatively simple, so it's not a big problem to derive a good table structure to represent almost all of the SKOS features in tables. And all of this gives a very low barrier to contribute. So this was the basic idea, and then there are several components which we developed, which are the solution. So first thing is that there's a command line application voc4cat tool, and this does the conversion from XLS to Turtle, but it can also convert in the backward direction. And then it also creates HTML documentation for the SKOS vocabularies. Then there's another repository. It's a template repository. So if you also want to develop, or I mean, create such a community managed vocabulary, you could just do it based on voc4cat template. And it's really, I mean, like 5 minutes work probably, and then it will work for a new vocabulary. So this is completely independent from our application, these both first tools. So voc4cat tool is general use, and voc4cat template also has no branding for catalysis. And then there's our application of these tools. That's voc4cat, and that's the vocabulary for catalysis related disciplines. And this is derived from the template. And if we do template updates, we really update the template repository and then sync or merge the changes into voc4cat. So there's always just one source of the pipeline. Another thing which we hardly use, but it's there to play around, there's a voc4cat playground, which is just creation of based on the voc4cat template. So there you could create test the submission process. Okay, so then I have more details on the components of that we developed. So the first thing is voc4cat tool. That's a Python command line tool. And it's initially was based on RDF-lib vocexcel, but currently, so there are 400 commits and maybe 100 are from vocexcel. So it's really has been becoming its own tool. And it's distributed via PyPy. It has a BSD3 clause license, so you could freely use it. And if users want to use it locally, because it's quite nice to test your Excel or maybe to convert it into different representations, you can also just pip or pipx install it from PyPy. The main features are that it's a bidirectional conversion between spreadsheet and SKOS Turtle. And then it has also integrated validation for the spreadsheet, and that is based on Pydantic mainly. And then for Turtle SKOS, we use a voc profile and PyShackle. The documentation generation is done via PyLoad, but there we needed a custom version to fix some bugs and adjust it to our multi-version handling. Then we use from Charlie Hoyt the Kuri-Uri support with his package, which was quite nice. Then also for the conversion between the different forms. And then we use, of course, GitHub Actions to do all the testing and creation of releases. And we have also set up Xenodo integration so that every time we create a new release, then Xenodo DOI is created. Next thing is the template. So the template repository contains the CI pipelines for the vocabulary, whereas the tool is just a tool. Yeah, so it has no CI pipelines related to vocabulary management. Then this is set up to support multiple versions. So we distinguish between a development version, then stable version, and then all past releases, which are identified by their date. Then this template repository includes some issue templates, which probably everyone wants to use. And then we have also a vocabulary and PID configuration file, which is part of this approach. And also this one is integrated to Zenodo. Yeah. And another point I just mentioned, so when we update the CI pipeline in code, then we can just git merge it to the vocabulary that we created based on it. And so Voc4Cut is finally the application of all of this. So we use persistent identifiers managed via W3ID.org. And that also allows us to use content negotiation to serve HTML for the human visitor with a browser, but you can also get Turtle for machines by supplying the accept header when you download it. And the documentation that is generated is hosted directly on GitHub pages. And here's a screenshot. So it's showing, so you get really the full documentations, the latest release one, the in development documentation, but also we keep all the past releases with their documentations. It's all in GitHub pages, so you don't have to host it anywhere else. And then, of course, we have configured this repository to require approvals to allow this editor feedback and merging only if two people agree and so on. And when we create releases, also here we create a Zenodo DOI entry for every new release in the Voc4Cut repository. So here are some screenshots. First, this is the Excel sheet. So it has 3 tables. There's also one describing the concept scheme, so who's the author and so on. And so what you see here is the main sheet. It's the concept sheet where we collect the preferred labels in different languages if you want, the definition, the alternate labels, and then children IRIs, so to express hierarchies between concepts. And also who is the contributor of this concept. So and here you see this is set up to use the Excel tables where you have filters and search and all this to ease the editing process. Then from this Excel, we generate then Turtle in the pipeline, and the Turtle is formatted like this so that it's easily diffable and can be well read also in an editor. And here you see our W3ID.org integration. So if you click on this, you will be redirected to the actual concept. So what I want to just say, so in Git, we just store each concept individually. So it's kind of important if you want to diff and see changes or use the blame function to know who did what, then to have the file small. So we store just one file per collection and concept, and then on the pipeline, when we run the pipeline, we generate a file with all concept as a single file, which is more convenient if you want to use it in external tools. Okay, so then this is a larger view of the documentation. So if you click on this, on the concept, it like here I said, you click on this concept 002, which is photocatalysis, I think, or material. Then you will be redirected to this page, but we use hash redirects here, you see in the URL. And so you are directly scrolled, so the browser scrolls directly to this concept. So it's quite convenient that you directly, see what you get. And if you try in other ontologies, that is not very often implemented. So you often just go to the landing page, although you want to see a specific class or concept. But here we have fully integrated with the scrolling to the right hash ID. Okay, so just let me summarize. So we have developed some new tools to help with the collaborative vocabulary development using GitHub and spreadsheet Excel, XLSX. And we are currently using it in NFDI for CUT, and there the last month it's really working well. So there were no big issues anymore. And the solution is highly integrated. Yeah, so we have the Zenodo integration. We use citations in GitHub, and use the pipelines for release process. We publish automatically to Python package index and so on. And so I think it's really has reached some good quality so that it could be used by other initiatives. Okay, so this is then in principle in NFDI for CUT, we are just working on building up the terminologies expressed in SKOS for the various catalysis subdisciplines, and this will be our basis for further ontology and data model development. And in general, that's probably what's clear for everyone here, that the shared terminologies and ontologies are a key enabler for fair data sharing. Just a final slide, an outlook. So we have some ideas about the next generation for our Excel template, and I've linked an issue here where you could see where it will go to. The key points are that we want to improve user experience for larger concept schemes. So if you have many concepts, expressing hierarchy is not that nice at the moment, and we want to improve that. And another thing is we want to improve the management of memberships in the collections. Then another idea is that the handling of obsolescence of concepts and collections is not really solved so far in this VocPub profile also. And that would be something worth to have, so that you could say, okay, this concept is replaced by another one, or just, removed because it was a bad idea or whatever. Okay, so, and for the vocabulary in catalysis, we have about 2,500 concepts waiting, that we need to clean up further before we merge it really into the GitHub Voc for CUT repository. And another thing is we need to update our guidelines which is more, domain expert targeting document how to work with this. Yeah, so thank you for your attention.